Building an AI system from scratch can feel like sorting through pure chaos. We are going to organize that noise into a clear, actionable blueprint. By the end of this workflow, you will have a complete decision map. You will know exactly how to structure your algorithms and choose the right learning methodology for your specific goals. You only need two things to follow along: a specific business or technical problem to solve, and a basic dataset to work with. Once you have this blueprint, you stop watching artificial intelligence happen from the sidelines. You become a builder, ready to process your own data. At its core, artificial intelligence is simply the field of computer science that enables machines to perform tasks requiring human intelligence. We start our layout here with the algorithm. This is the foundational set of rules, or step-by-step procedures, that guide a machine to perform a task. But static rules have limits, so we upgrade to machine learning. This allows the system to learn from data, finding patterns and making decisions without explicit programming. Establishing a machine learning foundation means you no longer have to manually anticipate every possible scenario. You let the data dictate the rules. Step 2 requires a choice based on your data. If you already know the exact prediction you want your model to make, you take the first fork in the workflow. This path requires supervised learning. It is the specific methodology you use to predict specific outcomes based on historical examples. To build this, you feed the system labeled data. You give the machine inputs with the answers already attached, like a batch of images explicitly tagged cat or dog. The system studies those relationships until it can process a brand new, unseen input and accurately apply the correct label on its own. When you possess historical, tagged data and require highly specific predictive accuracy, supervised learning is your definitive path. You won't always have the answers up front. Often, you will face massive amounts of raw, untagged data, like thousands of unstructured customer purchase histories. When labels are entirely absent, you apply unsupervised learning to organize the noise. Notice the contrast on the screen. Unlike the explicitly labeled folders on the left, the right side shows unsupervised learning in action. The system identifies hidden patterns and automatically clusters the unstructured data into related groups. When you don't know exactly what you are looking for, unsupervised learning parses raw data and returns structured, actionable categories. Datasets are static, but some models have to interact with dynamic environments. This is a requirement in robotics, where machines are designed to perform tasks autonomously. For these interactive models, you route your workflow to reinforcement learning. Look at how this avatar moves through the maze. It operates on strict feedback loops. It receives a penalty for a wrong action, like hitting a wall, and a reward for a correct decision. The system learns through continuous trial and error, constantly adjusting its actions to maximize its long-term success in an unpredictable environment. Eventually, standard machine learning hits a processing limit. Tasks like computer vision, understanding images and videos, or natural language processing require a heavier computational lift. To process these complex, multifaceted inputs, you escalate to deep learning. Deep learning relies on neural networks. These are computational models inspired by the architecture of the human brain. As complex data, like a dense cluster of raw pixels, flows left to right through these interconnected layers, the network recognizes microscopic patterns and outputs a high-level translation. Scaling up to deep learning allows developers to process the reality of human language and vision into complete machine understanding. This schematic shows your completed AI workflow blueprint. It tracks the entire sequence from raw data through methodology selection to the final output. The logic is straightforward. Establish your algorithm, choose a learning methodology based on your data type, and scale to neural networks when the task demands it. Look at your own dataset right now. Evaluate its status and determine if you are working with labeled answers or unlabeled information. Map that data to this decision tree. You have the explicit structure, and you are ready to build your first custom AI model.